Okay, this is a test review for the domain and range for Secondary Math 1. Domain and range is just basically a way of simplifying or looking at just one aspect of your graph. If you remember on coordinate planes, we have basically two planes here. It's a two-dimensional image, right? We have our horizontal plane, which is our x-axis, and we have our vertical plane, which is our y-axis. When we talk about domain, we are just talking about what's happening to our line horizontally. So basically, because this is a continuous line, and we have these arrows on the end, right? These arrows mean it keeps going on forever that way, and it keeps going on forever that way. If we just break this down to the horizontal aspect of the graph, we're just basically looking at all the x values that are covered by this line. So we can express that by using something called interval notation, which we did with the inequality system, where we basically say our interval covers from this least value to this greatest value. So when we look at domain, we're looking at our horizontal. If we were to squish this down to the x-axis and just look at what our line is doing horizontally, squish it down, if this is going over forever this direction and up and over this way, if we squish it down, our domain is just going to be negative infinity to positive infinity. Because if we look at this line with these arrows going on forever, the domain is just going to keep going on forever. And again, these are easy points on the test because anytime it asks for end behavior, you know your domain is going to be negative infinity to infinity, because in order to do end behavior, your x has to go to negative infinity and it has to go to positive infinity. Now range, on the other hand, is when we're looking at our vertical aspect of the graph. So what it's doing from bottom to top. Now when our line curves like it does here, this is an exponential equation. If you guys recall with exponential equations, they create what we call a horizontal asymptote, which is basically a point on the line where our y values get smaller and smaller, but they stop going beyond a certain point. This happens because there are negative exponents, which are just fractions that are getting smaller and smaller and smaller. So as we go this direction, the y values are just becoming smaller and smaller fractions, getting closer and closer to -4, but they never actually go below -4. So basically, as we go this direction forever, our y value is going to be infinitely close to -4 without ever actually getting it. So we're going to say -4 is the least value, and then as we go this way, our y value is getting greater. So when we squish it down, we'd have a -4 to infinity, basically, would be our range. Now, we're going to use a parenthesis next to this -4 because it never actually equals -4. If it had hit -4 exactly, we would use a bracket, something like this. But since it never equals -4, we use a parenthesis. And then end behavior, when you're going to negative infinity on the x-axis, remember the negative values on x are to the left. So when we go to the negative infinity, we want to look at what our y values are doing as we go to the left. And remember, like I said, this is a horizontal asymptote. So as we go this way further and further, it's getting infinitely closer to -4. So as x approaches negative infinity, our y value is going to be approaching -4. Then as we go to the right side, or to the positive infinity on the x-axis, our y value is going up and up and up and up and up and up and up. So as we go to the infinity, y is also going to the positive infinity on the vertical aspect. So we would say positive infinity there. And then our x and y intercept, these are just the points on the graph where our line is crossing. The x-axis would be the x-intercept, and when it crosses the y-axis would be the y-intercept. And remember, that is the point, so you're going to have an ordered pair where these cross. So it's crossing the x-axis at 2, so the point would be 2, 0. And it's crossing the y at -3, so the point would be 0, -3. And then to tell if it's increasing, decreasing, or constant, again, you read it like a book, from left to right. So as we go from left to right, our line is going up, so it is increasing. Now let's do another example with the end behavior. So let's look at number 3. So again, these have arrows on the end. And it's already pretty much squished horizontally with arrows on each end. It's saying that it's going forever to the left and it's going forever to the right. So our domain would just be negative infinity to infinity. However, our range, because this is a horizontal line, it's never going to go up from that point or go down. So if we squish this all the way down to the y-axis, all we have is one value and -8. It will always be -8. No matter what the x value is, it is always -8 because this is a horizontal line. So it equals -8, so we use brackets, show it is equal to -8. And then as x goes to -infinity, what's our y value doing? Well, it's not going up or down, it's staying at -8. So if we go all the way over to -infinity, our y value would still be at -8. In the same way, if we go to the positive infinity, we're not going up or down, so if we go all the way over to the positive infinity on the x, our y value remains at -8. Now, because it's not going up or down, and the x-axis is up here, we're not going to have any x-intercept, so we can just write none. But it does have a y-intercept right there. It's going to intercept the y-axis at 0, -8. And increasing, decreasing constant from left to right, it doesn't go up or down, so that would be a constant. Okay, then let's look at some functions on whether or not, and describe if they're functions or not. So remember guys, if you are trying to figure out if something is a function or not, the general definition of a function is that for each input, there's only one output. So like on these function maps, the left is your inputs, the right is your output. So -1 has one output of 6. 2 has one output of 8. If it just ended right there, this would be a function. However, 0 has two different outputs. It has an output of 3 and an output of 9. Now because that has two outputs there, this is not a function. A function can only have one output for each input. So like over here on number 8, each input only has one output. Even though these have the same output, 4 still only has one output, 5 still only has one output. That's still okay, that means this is still a function. It would only not be a function if one of our inputs had two outputs. And then to do the domain and range from a set of points, remember, domain is what's happening horizontally. If we're looking at points, the x values would represent what's happening horizontally. So because these are not continuous, we can't use interval notation. So what we use are these little braces here, which I just call little squigglies. And I draw them as like a little 3 there, backwards 3. So just like if we were doing interval notation, we're going to order these numbers from least to greatest. So the least x value is -6. The next least is 1, then 2, then 4. And we close that off with a squiggly. Now we do the same thing for range, but instead of x values, we're going to do the y values. So the least y value is -10, then -2, then 4, then 12, and we close that off with a square. And then to figure out if these is a function or not, when we're dealing with the coordinate plane, x would be our input and y is always our output. So we're basically looking to see if there's any x value that has more than one y value. Since none of our x values repeat, this is going to be a function. If we did have a repeating x value, like on number 10, -13, and right there, we would look at the y values. If we have two different y values attached to -13, that is not a function. Alright? And then you would do the same thing with tables as far as how you would do the domain and range. You would organize your x values from least to greatest, and you'd use the squigglies, so 0, 3, 6. And then you do the same thing with the y values, least to greatest. So -24, -18, -12. And that's how you do that. And then the last thing determining the domain and range of like some kind of shape or line. With a circle, it's actually pretty easy. Domain is what's happening from left to right, right? So if we squish this circle down to the x-axis, our least x value is right there, our greatest right there, so domain would just be -3, 2, 3. And it does actually hit -3 and 3, so we're going to use brackets to close this off. And it's actually the same range, -3, 2, 3, vertically. So if we squish that down vertically, -3, 3, in brackets. But with the graph, to determine this as a function, we don't have like any points to look for repeating x values, but what we do with the graph is we do what we call the vertical line test. If we can draw a vertical line, and it hits the graph line more than once, that means that at that x value, there are two outputs, or two y values. So like right here it hit, and right there it hit, that means this is not a function. Okay? So make sure you guys are ready for the test tomorrow. It'll look just like this, so steady up.